are beginning 7-1, which is graphing the sine and cosine curves. We will graph tangent curves, but not right now. Just today we're working on sine and cosine. Now, I want you to understand where these graphs, these points come from. So in the beginning, I'm going to be showing you where these points come from. Because if I just show you the graph of the sine curve, here's the sine curve right here. That's it. You're not going to know where it came from. So in order for this to make sense, we're going to start by doing the actual graphs. I'm going to show you where the points come from. But after you guys learn the tricks, you don't have to do this T-chart. So in the beginning, it's going to be tedious, but then it gets easier. Once we get to the worksheet that you have on the back of this packet, hopefully by the time we're done with it, you'll say, oh, that's easy. Okay, so right here, on the front of these notes that I made, there is a typo. And see if anyone can find it. Typo. I typed something wrong.
Found it.
No, you didn't.
Okay, so let's go through these. What this mumble jumble is, these are the angles and these are the ratios. Okay, this is the unit circle. You guys know this as 0 pi over 2. We're going to use this a lot right here. This is going to be used a lot. So the point, the degree of 0 or 0 radians, the ordered pair is 1, 0. For pi over 2, it's 0, 1, negative 1, 0. 3 pi over 2 is 0, negative 1, and then back to 2 pi is 1, 0, right? You also learned that a 30-degree angle is the same as pi over 6. A 45 is pi over 4. A 60 is pi over 3. You know backwards and forwards now these triangles, right? A 30 of 1, 2, root 3. A 45 is 1, 1, root 2. And then you have your three ratios, sine, cosine, and tangent. What's the definition of sine? It's opposite over hypotenuse or y over r. You're going to use y over r. What's the definition of cosine?
X over R.
And what's the definition of tangent?
Y over S.
Did you find the error?
Yeah.
Where is it?
The one you're
Right
pointing
there. This should be y over x, so please fix that. All right, now, here is your graph of the sine curve. So you might see the equation as f of t is equal to sine t, or you might see y is equal to sine t, or you could see you'd probably, my favorite is y equals sine x. Well, if we need a t-chart, what is x and what is y? What are we comparing? X are going to be the angle measures, and y is going to be your ratios. Now we're talking about the sine curve, and the sine is defined as y over r. So my favorite points to use are 0, and I'm leaving space here for a reason. Pi over 2, pi, 3 pi over 2, and 2 pi. Now, if I talk about these 5 places, what am I talking about? I'm talking about right here. Here's 0, here's pi over 2, 3 pi, 3 pi over 2, and 2 pi. So at these 5 spots, 1, 2, 3, 4, and back here again, can you tell me what the definition of sine is again? It's y over r, and remember r is always 1. So at 0 radians, what's the y value right here? 0 over 1 is 0. So where is, remember we said the x-axis is going to be the angles. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So here's 0, 0. And then the y value is your ratios. So 0 is 0. Now what about pi over 2? Where is pi over 2? Here's pi over 2 right here. In this ordered pair is 0, 1. Sine is y over r. 1 over 1 is 1. So at pi over 2, we're going to go up 1. That's this point right here. How about pi? Here's pi. -1, 0. What's the y value over the r value? It's going to be a 0. So at pi, we have a 0. That's that point. How about 3 pi over 2? Here's 3 pi over 2. It's 0, -1. The y value is -1 over r, which is 1, -1. So at 3 pi over 2, we're going to go down 1. And we're back at our starting point, 2 pi, which is right here, which is 1, 0. The y value is 0, 0 over 1 is 0, and that's 0. Well, so far we got these points right here. Well, what about these other angle measures? Well, what other angle measure is between 0 and pi over 2? What other angle measures do we know? How about pi over 6, pi over 4, and pi over 3? Well, what is this? A 30, that's a 45, and that's a 60. Those are these points right here. And you know what? There's infinite angles in between these, but these are the ones we see a lot. So in reference to a 30-degree angle, here's a pi over 6. If you think about a 30-degree angle, here's your 30-degree angle. What's the definition of sine? Opposite over hypotenuse. So this is a 1 to 2 ratio. What's another name for 1 to 2? A half. So over pi over 6, up a half. We're right on the mark right there. How about pi over 4? That's a 45er. Pi over 4, that's a 45er. We've got 1 over root 2. Now, I don't know what 1 over root 2 is unless I typed it into my calculator. It's about 0.71. It's less than 3/4. So over pi over 4 up, that's about 0.71. And then a 60-degree angle, pi over 3. 60 degrees, go to the triangle, 60 degrees, that's opposite over hypotenuse. Root 3 over 2 is approximately, if you used a calculator, 0.87. So over pi over 3 up 0.87. And if you continued, we're not going to do it because it would take forever. If you did the other angles, like 2/3 pi and 3/4 pi, and 5/6 pi, you would see that you get these points right here. If you did the ratios. And then if you did these ones, these are quadrant 1, this is quadrant 2, this is quadrant 3 from here to here, and then this is quadrant 4. So if you can remember this sine curve, this is how you were taught last year. On, above, on, below, on. That's the sine curve. Did you remember that from last year? On, above, on, below, on. So you start at 0. Do you remember this last year?
Yeah.
No?
I did.
We did it a little bit. We didn't do a lot. Now, what's going to change? What's going to change with these graphs? So, see these 5 dots here? 1, 2, 3, 4, 5. That's what we just graphed. You need to understand that this pattern continues. The on, above, on, below, on, it's going to continue. After 2 pi, it goes on, above, on, below, on. It will continue on, and it goes on, and on, and on, and it goes the other way too. So that sine curve continues. So if we were to extend this graph, you would get the one like on the left, but it continues. And one full period is the cycle from here to here. And then the pattern repeats itself. So this is called from 0 to 2 pi, that is one full period. And then that period continues, the cycle continues. Now there's some words we need to talk about. The maximum value. What is the maximum value here? What's the highest number it reaches? 1. And the minimum is 1. This is the max, and this is the min. The amplitude is how high this thing is off the x-axis. So it's, you never say it's -1 units off the x-axis, it's 1 unit, think of absolute value. So this is 1 unit, okay, that's the amplitude. Now what gives you your amplitude is the number in front of the equation. Like this says y equals 2 sine t. You guys learned back in chapter 3, what does a number do if you have a function, any function, like so for example, if I gave you this, what does that 2 do? It's a vertical what?
Stretch.
Vertical stretch by a factor of 2. What does it do to your, remember when we did a table? What did we do with this thing? We multiplied the y values by 2, right? So if you take those 5 points that we talked about, what were they? 0, 0. We did pi over 2, 1. We did pi, 0. We did 3 pi over 2, -1. And we did 2 pi back to 0. It was on, above, on, below, on. Now this is the graph of that, but I'm going to show you, this is the parent function right here. Here's your parent function. It looks like this. On, above, on, below, on. This is the parent function. That's the parent function. What does that 2 do? You're going to multiply the y values by what? By what? 2. If it were a 3, if it were a 0.5, you're going to multiply all these y values by 2. Can we do that? You get 0, you get 2, you get 0, you get -2, and you get 0. So what they have here is plotted 0, 0, pi over 2, I'm sorry, 0, 0, pi over 2, 2, pi 0, 3 pi over 2, -2, and 2 pi 0. So now, can you tell me what the period is? The period is still one complete cycle. It went from 0 to 2 pi. What's the maximum value here? 2. The minimum is -2. The amplitude, how many units off the x-axis are you? That's your amplitude. Your domain for all of these will be all real numbers for sine and cosine. Your range, what's the highest and lowest y values you have? 2 and -2. So the range goes -2 to 2, and we're going to use brackets because it's including 2 and -2. Now let's look at this one. Y equals negative sine t. Or you could say sine x. So we have x and y. Doesn't matter. Sometimes I use t, sometimes I use x. But the points that we're going to use, again, you're going to get really, the more you write this, the better you'll memorize it. Okay, can you give me the points? So 0, 0, pi over 2, 1, 0, -1, and 0. What does this negative mean? Well, it's going to be a reflection over the x-axis. How do you reflect something over the x-axis? You multiply the y values by -1. So if we multiplied this by -1, you'd get still 0, -1, 0. This is going to be a positive 1 now, and that's still going to be 0. So if we graph this, 0, 0, so instead of going on, above, on, below, on, now you're going to go backwards. You're going to go on, below, on, above, on. So this whole thing, it normally looked like this. But because of the negative, it's reflected over the x-axis. So you've got a choice. You can sit there and make a t-chart and do what I just did, but it'll kill you, or just remember the on, above, on, below, on, like that, and just do it that way. All right, so now we're going to start to see something else added. Not only do you have a vertical stretch, but now we are doing what to this problem? What do you think that +1's going to do?
Shifting.
It's going to shift your graph 1 unit up. So this is gonna be your new x-axis. I want you to make a broken horizontal line at y equals 1. That's your new x-axis. And now from here, this is how fast you're gonna graph these. What did the sine curve look like? It was on. There's on. Now at pi over 2, you're going to do an amplitude of 3. So on, above, on, and now you're going to go at 3 pi over 2, you're going to go below 3 units.
You did the first one.
Did I? 1, 2, 3. No, there's 3
Oh,
here.
yeah, yeah,
1, 2, 3. See, that's 3, that's your amplitude. This is 3 units right here. And then on. So this is what your graph looks like. It starts on, and it goes to 4, and then it goes on, below, and on. But you need to understand that the amplitude is 3. So the period, let's fill this chart in. The period is 0 to 2 pi still. What's your maximum value here? 4. What's your minimum? -2. What's your amplitude?
3.
It's 3. Your domain is going to be all real numbers. Can you tell me your range? -2 to 4. Now I'm going to show you a trick. Make sure you put the smaller number first. Here's a trick on how to find the range on these. This is what you're going to do. This is how I do it. You're going to have a question on your test. It's going to ask you, what is the domain and the range of this? This is how you do it. 3 times, put a 1 here, and add that number, and 3 times -1, and add that number. What is 3 times 1?
3.
Plus 1 is?
4.
That's that number. And then what's -3 plus 1? That's that number. So let's say I asked you 5 sine x minus 4. Tell me the range. You're going to do 5 times 1 minus 4 and 5 times -1 minus 4. So you get 1 here, and so your range is from -9 to 1. And it works. Okay? So you do the 5, you do this a value times 1 and -1, and then add the d value. So what are you seeing here? This is what you should see. That a value is your amplitude, or the height over the x-axis, and the d is the vertical shift up and down. And this whole graph, this information holds true for the cosine curve. Now the cosine curve, what's the definition of cosine? Cosine is x over r. So let's see what this thing looks like. Here's your unit circle. And again, once I do this T-chart, you don't have to keep doing it. But this point is 0, 1. This is 0, 1. -1, 0. And 0, -1. Okay, so let's just do the main. We don't have to do the 30, the 45, and the 60. Let's do 0. Let's do pi over 2. Pi. 3 pi over 2. And we're going to do 2 pi. Using the definition of cosine. Cosine is x over r. So right here, what's the x value? 1. And what's r? 1. What's 1 over 1? So 0, 1 is where? Right there. That's that first point. So where the sine curve started at, it was on, above, you're going to start above for the cosine curve. You're going to start 1 unit above. Do the next one, pi over 2. What's the x value? 0 over 1, which is 0. So pi over 2, 0. That's that point right there. Then you do pi. What's the x value? -1 over 1, which is -1. Where's pi -1? Right there. And 3 pi over 2 is right here. Your x value 0 over 1 is 0. And 2 pi, which is back here, you've got 1 over 1, which is 1. So we have 3 pi over 2, which is 0, and that one. So here is your cosine curve. What do you see? I'll tell you what I see. What do you see? What does that look like to you? A V? A parabola? I want you to memorize it.
Oh, wine.
Looks like a wine glass.
Martini.
Third hour said a martini glass.
Well,
So that's how I remember it, okay? Now, again, your period is 0 to 2 pi. Your maximum is 1, your minimum's -1, your amplitude is 1, your domain is all real numbers, and your range, again, is from -1 to 1. That's the parent function. Let's just talk about this negative cosine one. So, the negative tells you what? It's a what over the x-axis? Reflection over the x-axis. Or you could think about it by multiplying the y values by -1. So what y values are you talking about? You're talking about, if you looked at this table here, the one we just did a second ago, if you multiply these by -1, if you multiply this by -1, what would you get? You get 0, -1. Pi over 2, still going to be 0. Pi, you're going to have now a +1. 3 pi over 2, you're going to have still 0, because 0 times anything is 0. And 2 pi, you're going to have a -1. That's by multiplying all these by -1. So let's check it out. Let's just show you that why this works. So 0, -1 is that point right there. Pi over 2, 0, that's that point. Pi is +1. 3 pi over 2 is back to 0. And 2 pi is 0. So what happened to your cup? It's upside down. There's your cup. So now, what do you think you're going to do when they give you a -2 here and a +2 here? Well, this -2 is your new x-axis. So what you're going to do is draw a broken line at -2. And now, do this process right here. What's 2? 2 is your amplitude. So now we're going to start 2 units higher than the new x-axis, that's your amplitude, and draw your cup. So it's above, on, below, on, above. So that's going to be your graph. Make it curvy. And you know this pattern continues, but we're only doing one full period. So let's fill this out. Our period is 0 to 2 pi. What's our max? Actually, we should have brackets there. Our maximum is going to be 0. Our minimum is -4. Our amplitude is 0. Domain is all real numbers. And your range is -4 to 0. Let's do my little trick here and see if that worked. What was my trick? 2 times 1 minus 2. And 2 times -1 minus 2. Do we get 0 and -4? Yes, we do. That's our little shortcut to find the range. Okay, one more. You're going to see the absolute value of the sine curve. Can you give me the parent function? 0, pi over 2, pi, 3 pi over 2, and 2 pi. So the sine curve was on, above, on, below, on. But what do they want? They want the absolute value of these. What's the absolute value of all these numbers? What's the absolute value of 0? What's the absolute value of 1? 0, 1, 0. So this is what you're going to graph. You're going to graph 0, 0. You're going to graph pi over 2, 1. You're going to graph pi, 0. And now what's gonna happen, it goes like this, and then it's gonna bounce, 3 pi over 2, it's gonna be 1 again. And then, so it looks like a bouncy ball. Questions? So your period, 0 to 2 pi, your max, 1, your min, 0, your amplitude 1, your domain all real numbers, and your range is going to be from 0 to 1. Okay? Now, these are your homework problems. I want to start this off with you guys. See how many of these we can get. By the time you're done with this worksheet, you will understand it completely. You'll know the tricks. So start with, and these little dots are going to make you sick. So just bear with me here. They're like, can you understand that between here and here? This is really pi over 2. I can't even write it. It's so small. That's why, you guys. Pi over 2. This is 3 pi over 2. And the reason why they're so small is so I can fit, without wasting paper, all these graphs. So, how are you going to graph cosine t minus 2? Step 1 is to draw your new x-axis. Where is your new x-axis? It's at -2, right here. And your amplitude is 1. What does the cosine curve look like? It starts above the x-axis, and it's only 1 unit because that's the vertical stretch, 1. You're going to go above, on, below, on, above. Now they want you to do from -2 pi to 2 pi. So we've got to go backwards now. You got to go this way, and that's your graph. You want to draw it as smooth of a curve as you can make it. And there's your graph. From -2 pi to 2 pi, that's because of the directions. Let's do another one. Number 2. Where's your new x-axis? At +1, right there. Now this is the sine curve. The sine curve starts on. It's on, above, on, below, on. Like that, and then go backwards the other way. So you're going to go down, on, questions? Number 3 is written to confuse you. Can you fix it the way it's written? Anyone?
Negative sine, x plus 4, or t plus 4.
Yep. Yep. You got it. So where's your new x-axis? F4, which is right here. Now normally the sine curve starts on, it goes on, above, on, below, on, but because it's a reflection, it's gonna be on, you're gonna go backwards. Like this, and then keep like that. Number 4. Where's your new x-axis? 3. Make your broken line. Now normally the cosine curve starts above, but because it's negative, you're going to start below. Number 5, we just did this one in our notes. What does the sine curve look like? It starts here at the origin and it goes up and down. That. And then they want you to do the other way. Now, normally this cosine one, the difference between the sine absolute value and the cosine, I'm gonna show you, I'm gonna do this one without the negative. Ignore that negative for a second. This one looks like this. See if you can understand, see the difference. So, what's the major difference between these ones? That's if they were both positive cosine. What do you notice about these hills? One looks different. One's the cosine one and one's the sine.
One has a point on the origin.
It's shifting.
Yeah.
Yes.
One starts on and one starts above.
The sine one splits it right in between here. Well, this one splits it right in the middle. That's the difference between them.
118.
So now, if you really want to graph this one the correct way, this is going to be all flipped upside down, so it looks like, it actually is going to look like this. Oops, I meant to do that. It looks like this. So really, this is not the correct answer. That is. But the difference is that the sine one splits it right in between the two, and the cosine is right in the middle of it. So finish these for homework, and we will go over these tomorrow.